Hello there, welcome to Dreamy Science. Maybe you're listening in the quiet of your room. The lights already dimmed. The world outside hushed for the night. Maybe you're tucked into bed. Blanket pulled up, pillow soft beneath your head. Where are you listening from? Wherever you are, let's begin together with a question that sounds impossibly big. How old is the universe? Not the Earth. Not the trees or the mountains or the oceans. Not even the sun or the stars you see above. But everything. All of it. The whole sweep of space and time. How old is forever? It seems like the kind of question a child might ask, sitting under the night sky, pointing at the stars. A question too big to answer, too wide for numbers to touch. And yet, scientists have dared to try. Not only to ask, but to measure. They've placed numbers, precise numbers, on something as vast and intangible as the cosmos itself. 13.8 billion years. That's the number you'll hear again and again. A specific age, as if we'd gone to the universe's birthday party and checked the candles on the cake. But how could anyone possibly know? How do you measure something so large, so unreachable, so far beyond our small, short lives? To begin, you have to shift the way you think about time. Human time runs on clocks and calendars, days and years, holidays and birthdays. Cosmic time runs differently. Its clocks are not made of gears or glowing digits, but of atoms, of light, of the stars themselves. To read those clocks, you have to be willing to stretch your imagination. Let's start close to home. The Earth itself has kept a diary, though not one written in ink. Instead, it's written in stone. Deep inside rocks, tiny atoms are ticking away like invisible clocks. Some atoms are unstable. They break down slowly, predictably, in a process we call radioactive decay. Uranium turns into lead, thorium into radium, always at the same rate, always ticking off the years with perfect patience. When geologists measure the ratios of these atoms inside ancient rocks, they're reading a record billions of years old. That's how we know that Earth itself is about 4.5 billion years old. Not just a guess, but a calculation written into the planet's bones. This idea that matter itself contains clocks was our first glimpse of deep time. It told us that the world wasn't a few thousand years old, as once imagined, but staggeringly ancient. Older than civilizations, older than mountains, older even than the oceans. And if the Earth is billions of years old, then the cosmos that holds it must be older still. The rocks beneath our feet became a kind of ladder, lifting our perspective up and out. But radioactive atoms are only one kind of clock. Lift your eyes, and you'll see another. The stars. Stars live lives just as people do. They are born in clouds of dust, grow bright and hot, and eventually fade or explode. And like lives, their spans can be measured. A star's brightness, its color, its chemistry, all whisper its age to those who know how to listen. Some stars are as young as children, glowing blue and fierce, burning through their fuel quickly. Others are quiet elders, red and cool, having lived for billions of years. By studying these stellar lives, astronomers realized that the universe must be at least as old as its oldest stars. And what they found were stars more than 12 or 13 billion years old. That discovery pulled the floor out from under our sense of time. If stars that ancient exist, then the universe itself must be older still, old enough to cradle them, old enough to let them shine their long lives out. By peering into the hearts of stars, scientists were, in a way, peering into the childhood of the universe. But it doesn't stop there. Beyond stars, beyond galaxies, there is light even older. A glow so faint you can't see it with your eyes, but so steady it fills the universe in every direction. The cosmic microwave background. The afterglow of the Big Bang. When scientists first detected it in the 1960s, it was like finding the universe's baby photo, still glowing softly from its earliest days. That light is more than 13 billion years old, traveling all this time just to brush against our instruments. Measuring it gave us not only the universe's childhood portrait, but also its birthday, about 13.8 billion years ago. Already you can see the pattern. The clocks of the cosmos are not clocks at all, but natural processes, written into matter and light. Radioactive decay, stellar lifetimes, cosmic expansion, the faint glow of ancient light. Each one tells a part of the story, and together they give us an age for everything we know. Not perfect, not final, but astonishingly close. Still, the number is not the most important part. 13.8 billion years is precise, yes, but it's the wonder behind the number that matters most. That humans, tiny, fragile, temporary creatures, can look out into the vastness and measure something as unfathomable as the age of the universe. That we can hold forever in our hands, at least for a moment, and whisper, "This is how old you are." So, tonight, as you drift between thought and dream, hold on to that number if you like. 13.8 billion years. But more than that, hold on to the wonder of asking and of answering. The rocks beneath you, the stars above you, the light still traveling through your room. They are all clocks, softly ticking, marking the age of everything. And tomorrow, when the sun rises and another day begins, you'll be part of that ticking, too. Imagine standing outside on a clear night, somewhere far from the noise of cities and the glow of street lamps. The sky above you is black velvet, scattered with countless points of light. To the eye they look eternal, unchanging, as if they have always been and always will be. But hidden in that stillness is motion, growth, and time itself. The stars are not fixed jewels, but burning engines, each living a life measured in billions of years. And in those lives, scientists have found some of their most reliable cosmic clocks. Stars are made of hydrogen, the simplest element in the universe. Inside their cores, under unimaginable pressure, that hydrogen is fused into helium, releasing energy in the process. It's the same process that makes the sun shine, the same process that lets you see your way home at night by starlight. But like a fire in a hearth, this fuel is finite. Eventually it runs low, and when it does, the star's life begins to change. That means the way a star looks, the color of its light, the brightness of its glow, is tied to how long it has been burning. Hot blue stars, dazzling but rare, burn their fuel furiously and die young, in just a few million years. Cooler red stars, small and steady, sip their fuel slowly and can last trillions of years. In between are stars like our sun, living for about 10 billion years before swelling into giants and fading away. By studying the different kinds of stars and where they fall on their life paths, astronomers can create a timeline of stellar evolution. One of the most important tools for this is something called the Hertzsprung-Russell diagram, a kind of family portrait of stars. On this diagram, stars fall into patterns based on their brightness and color. Some patterns represent youth, others represent old age. Clusters of stars, born together from the same cloud of gas, reveal their ages like siblings of different heights. The youngest cluster glows blue and sharp, the oldest glows red and faint. By comparing these stellar populations, scientists can read the ages of galaxies, and in turn, set lower limits on the age of the universe. But perhaps the most astonishing discovery came when scientists looked not just at individual stars, but at the oldest ones they could find. Some are found in dense swarms called globular clusters, hanging like lanterns in the halo of our galaxy. These clusters contain stars that are nearly as old as time itself, more than 12 or 13 billion years in age. When astronomers realized this, it was as though they had uncovered a diary written just after the dawn of creation. These stars had lived nearly the entire span of cosmic history. Their ages told us that the universe had to be older still, old enough to let them form, shine, and endure. It is strange to think that something so far away can tell us something so profound about time. Yet every flicker of starlight that reaches your eye tonight has been traveling not just across space, but across time. Some of those photons began their journey hundreds of years ago, others thousands, and some millions. Each star is not just a light in the sky. It is a messenger, bringing with it a record of its own age and the age of the cosmos. And there is a quiet poetry in this. When you look up, you are not just seeing where the stars are now, but where they were long ago. You are gazing into the past, into the history of the universe itself. The sky becomes a time machine, simple and silent, carrying the story of billions of years right into your eyes. So, when scientists say the universe is 13.8 billion years old, part of that number comes from these stellar lifetimes, these cosmic diaries written in light. They show us that time is not just something we count with watches and calendars. Time is written in the very fabric of the stars, in their colors, their brightness, their ages. They are clocks, vast and slow, ticking off the history of everything. And as you breathe in and breathe out, lying still beneath that night sky in your imagination, it's worth remembering. You are part of the story, too. The atoms in your body were forged in the hearts of ancient stars, stars that lived and died long before the sun was born. Your own existence is a page in that cosmic diary. Every heartbeat, every thought, every quiet moment of wonder is part of a timeline that stretches all the way back to the first light. Imagine for a moment that you could pick up a stone from the ground and hold it in your hand like an ordinary pebble. To most people it would look unremarkable, just another piece of earth. But hidden inside that stone is a story stretching back billions of years. A story written not in words but in atoms. The earth itself is a clock, and scientists have learned to read its ticking through the slow decay of radioactive elements. Some atoms are unstable. They begin as one element but slowly, over immense stretches of time, transform into another. Uranium becomes lead. Potassium becomes argon. Each transformation happens with incredible regularity, as if nature herself has built an internal metronome. The rate of decay is measured in what scientists call half-lives, the time it takes for half of a given sample to change. For uranium-238, one of the most famous of these clocks, the half-life is nearly 4.5 billion years, about the same age as the Earth itself. By measuring the ratios of parent atoms to their daughter products inside rocks, geologists can calculate how long those rocks have been around. It is a kind of cosmic bookkeeping. If you find a crystal that has collected argon gas from the decay of potassium, you can work backward to discover when that crystal first solidified. Do this with enough samples from enough places and a picture emerges. The Earth is old, very old, 4.5 billion years and counting. This was one of humanity's first real glimpses into deep time. Before radiometric dating, some believed the Earth was only a few thousand years old, a place with a brief history. But the atoms told another story, one far grander. They whispered that the ground beneath our feet had been here almost since the dawn of the solar system, forged from the same cloud of gas and dust that created the sun and planets. And if the Earth is billions of years old, then the universe must be older still. You cannot have a planet without a star to warm it, and you cannot have a star without galaxies and gas to form it. Already the atoms were hinting at a cosmos with a timeline stretching back far beyond human imagination. It is almost impossible to grasp such numbers. 100 years feels long to us. 1,000 years feels ancient. But 1 billion years is a scale of time so vast that even mountains rise and crumble within it. Continents drift. Oceans open and close. Entire species appear and vanish. And yet billions of years are what the rocks in your hand casually record, as if it were nothing more than another day. There is something soothing in this, if you let it be, to know that your life, fleeting as it feels, is nested inside an Earth that has been here for billions of years, and that Earth itself is nested inside a universe stretching back even further. The ticking of radioactive atoms is silent, patient, unhurried. It is the kind of time that doesn't care about minutes or hours, only about the slow, inevitable unfolding of existence. And so, lying here, imagining that pebble in your hand, you are also holding a fragment of forever. You are connected not just to your own small moment but to a timeline that began long before you and will continue long after. The atoms inside that stone, inside the Earth, even inside your own body, are keeping time in their quiet, invisible way. They remind you that the universe has been old for a very long while, and yet, somehow, it is still young enough for you to be here to wonder about it. If stars and stones tell part of the story, then galaxies tell the rest. Galaxies are not just random gatherings of stars. They are structures with histories, motions, and destinies. And perhaps the most important clue to the age of the universe came not from a single star or rock, but from the motion of galaxies themselves. In the early 20th century, astronomers were just beginning to realize that the fuzzy patches of light seen through telescopes were not clouds within our own Milky Way, but entire galaxies, vast collections of stars like our own, far beyond. Among the scientists studying these galaxies was Edwin Hubble, who noticed something strange. The galaxies weren't just sitting still. Their light was shifted, stretched toward the red end of the spectrum. It was as if they were moving away from us, and the farther away they were, the faster they seemed to recede. This discovery, called Hubble's law, was revolutionary. It meant that the universe was expanding. Space itself was stretching, carrying galaxies along like raisins rising in bread dough. And if space is expanding now, then in the past it must have been smaller, denser, and hotter. If you rewind the cosmic movie, you eventually reach a beginning, the Big Bang. By measuring the rate of expansion, scientists can estimate how long the universe has been stretching. It is like watching fireworks and calculating how long ago they exploded by measuring the speed of the sparks. The expansion rate is encoded in a number called the Hubble constant. Divide the current distances of galaxies by their speeds, and you get a rough age for the universe. Early estimates were uncertain, but over time the calculations narrowed in about 13 to 14 billion years. The beauty of this method is that it ties the age of the universe not just to a handful of stars or rocks, but to the very fabric of spacetime itself. The expansion is not happening in one corner of the cosmos. It is happening everywhere, all at once. And because it is everywhere, it tells us something fundamental. The universe had a beginning, a finite age, a moment when everything we see was compressed into a smaller, hotter state. There is a quiet strangeness here. The galaxies themselves are not racing through space like ships across an ocean. Rather, the ocean itself is growing, stretching, carrying them apart. The light from those galaxies, stretched along with space, becomes redder as it travels. That faint redshift is like a timestamp, a signature of the universe's age. So when you look up at the sky tonight and see the Milky Way arcing overhead, remember that it is just one galaxy among billions, all drifting apart in the slow dance of cosmic expansion. Each one is a marker of time, a piece of evidence that the universe has been unfolding for nearly 14 billion years. And that vast age is not hidden in some far-off laboratory. It is written into the very starlight reaching your eyes. Lie back, breathe deeply, and let that thought settle in. Every galaxy is a clock, every redshift a reminder. The universe is old, unimaginably old, but it is still in motion, still stretching, still alive with time. To understand cosmic time even more clearly, astronomers turned their attention to the oldest light of all, the cosmic microwave background. Imagine the universe not as it is now, filled with galaxies and stars, but as it once was, a hot, dense fog of particles and light. For nearly 400,000 years after the Big Bang, the cosmos was too dense and too hot for light to travel freely. Photons bounced endlessly from particle to particle, trapped in a cosmic haze. But as the universe expanded, it cooled, and eventually it became transparent. Suddenly, light could move, streaming freely across space. That first light has never stopped traveling. Today, more than 13 billion years later, it still surrounds us, stretched and cooled into a faint microwave glow. We call it the cosmic microwave background, or CMB for short. The CMB is like a baby picture of the universe. It is a snapshot of the cosmos when it was less than 500,000 years old. Scientists first discovered it in the 1960s, almost by accident, when two radio astronomers, Arno Penzias and Robert Wilson, picked up a faint hiss of static on their antenna. No matter where they pointed the instrument, the hiss remained. They even thought it might be caused by pigeons nesting in the device. But after much cleaning and recalculating, they realized they had stumbled upon something profound, the afterglow of the Big Bang itself. Since then, satellites have mapped this glow in exquisite detail. At first glance, the CMB looks almost uniform, the same temperature in every direction. But zoom in and you see tiny variations, slight differences in temperature and density. These subtle ripples are the seeds of everything, the structures that would one day grow into galaxies, clusters, and stars. By studying them, scientists can trace the timeline of the universe with extraordinary precision. The light of the CMB carries clues about the age of the universe. Its patterns reveal how fast the cosmos has expanded, how much matter and energy it contains, and what its geometry is. When all the numbers are combined, they point again to an age of about 13.8 billion years. Different methods, stellar lifetimes, radioactive decay, galaxy expansion, and now the cosmic microwave background all converge on the same conclusion. There is something deeply comforting in this convergence. It means the universe has been keeping its own time all along, and we have simply learned how to read it. The atoms and rocks, the glow of old stars, the stretching of galaxies, the whisper of ancient light, they all tell the same story in different voices. Close your eyes and imagine that glow still passing through the room around you. It is not bright or intrusive, but soft and constant, a kind of cosmic lullaby. Every second, ancient photons drift through your body, messengers from the dawn of time, reminding you that you are part of an unfolding story that began billions of years ago. Of course, the story of cosmic time is not as simple as picking a single clock and reading it. Scientists have found that each method of measuring the universe's age carries its own uncertainties, its own subtle disagreements. The Hubble constant, for example, the rate of expansion, has become the focus of one of the biggest puzzles in modern cosmology. Different techniques give slightly different values. When astronomers measure the expansion by looking at nearby galaxies and using standard candles like Cepheid variable stars, they find one number. But when they look at the cosmic microwave background and trace the expansion from the early universe forward, they find another. The two results don't quite match, and the difference is not small enough to ignore. It has become known as the Hubble tension, a kind of cosmic riddle. This doesn't mean scientists are lost. In fact, it may mean the opposite. Sometimes when measurements disagree, it is not because one is wrong, but because there is something new waiting to be discovered, some hidden ingredient in the universe we have not yet accounted for. Dark energy, dark matter, new physics beyond our current theories, all of these possibilities have been suggested as explanations for the tension. Think of it like hearing two different melodies played at once. They sound slightly out of tune with each other, but instead of being noise, the dissonance suggests there might be a deeper harmony yet to be uncovered. The disagreement may be a clue pointing toward a richer, more mysterious universe than we imagined. And yet, even with the tension, the broad picture remains clear. Whether the universe is 13.7 or 13.9 billion years old, the fact remains that it is ancient beyond easy comprehension. The Earth has circled the Sun only about 4.5 billion times. Human history covers mere thousands of years. Our entire story is a brief flicker in the great expanse of cosmic time. There is something humbling, almost soothing, in accepting this. The universe does not rush. As clocks tick on scales we can scarcely grasp. Stars burn for billions of years before fading. Galaxies drift slowly apart. Light crosses distances so immense that it takes longer than human civilization has existed just to reach us. When you lie down and let your mind drift, think of that slowness. Think of time not as the hurried schedule of hours and minutes, but as an ocean stretching beyond sight. Each wave of starlight, each ripple in the cosmic background, each expansion of space is part of that endless rhythm. And so the tension between measurements is not something to be feared. It is part of the wonder. It reminds us that even now, with all our telescopes and equations, the universe still holds secrets. Secrets that invite us to keep listening, keep measuring, keep asking how we measure forever. One of the most enchanting aspects of measuring the universe's age is how much of it relies on light. Light is our time machine. Every time you gaze at the night sky, you are looking backward through history. The stars above are not shining as they are now, but as they were when their light began its journey toward us. The nearest star beyond the Sun, Proxima Centauri, is about 4 light-years away. That means when you look at it, you see it as it was 4 years ago. The bright star Betelgeuse in Orion is hundreds of light-years away, so the light you see tonight began its trip around the time the Renaissance was reshaping Europe. And the light from the Andromeda galaxy set out over 2 million years ago, long before humans existed in their current form. The farther you look, the older the light. Some of the galaxies we see in deep-field images from the Hubble Space Telescope are billions of years old. Their light began traveling when Earth itself was a young planet. In a sense, telescopes are not just instruments of vision, but instruments of memory. They allow us to peer into the deep past, collecting photons that have crossed nearly the entire age of the universe. This connection between light and time is so intimate that astronomers sometimes describe space as a kind of archive. Each photon carries a record of when and where it was born. By analyzing that light, its color, its intensity, its spectrum, scientists can reconstruct the conditions of the cosmos long ago. Even the faintest glow holds meaning. A redshifted galaxy tells us about expansion. The spectral fingerprint of a star tells us its chemical makeup and thus its age. The whisper of microwave photons tells us about the universe when it was only a baby. It is as though the cosmos has been writing a diary in light since the beginning, and we are only now learning how to read it. Imagine closing your eyes and thinking of those countless streams of photons still arriving. They come not as a rush but as a steady, gentle drizzle, a rain of ancient signals falling across your skin and through your room. They do not weigh anything. They do not make a sound. But they are there, constantly carrying the history of everything. When we say the universe is 13.8 billion years old, we are really saying this: light has given us a record that stretches that far back. It is not a guess or a vague estimate, but a measurement anchored in the glow of stars, the fading of radioactive atoms, the expansion of galaxies, and the warmth of the cosmic background. Each of these is a clock, and together they tick in harmony, giving us the rhythm of forever. But there is something even stranger tucked into the fabric of cosmic time. The fact that the farther we look, the less we can ever know. This is because the universe has a horizon, a limit to what we can observe. Not because space ends, but because light has only had so much time to reach us. Think of it this way. The universe is about 13.8 billion years old, which means the most distant light we can possibly see must have been traveling for about 13.8 billion years. Anything farther away simply hasn't had enough time to reach us yet. This creates a kind of cosmic bubble around us, a sphere of what is observable. Beyond that, there may be more galaxies, more stars, perhaps even infinite space. But they are forever hidden, not because they do not exist, but because their light will never arrive. Astronomers call this the observable universe. It is not the whole of everything, but it is everything we can measure, everything we can know. And even within this bubble, things are moving. Because the universe is expanding, many galaxies are drifting away from us so quickly that their light is stretched beyond visibility. They slip over the horizon, not into darkness, but into inaccessibility. This means that the observable universe is not static. It changes with time. In billions of years, distant galaxies that we can see today will fade from view, their light stretched into invisibility by expansion. The universe is not just old, it is fleeting. The record of light we have now is precious, a gift of timing, because future astronomers may see less of the cosmos than we do today. There is a quiet sadness in that thought, but also a gentle beauty. It reminds us that every glance at the stars is unique, unrepeatable. The universe is offering us its story in chapters, and we happen to be alive for one of the richest ones. Imagine the horizon as a soft boundary in the night sky. Beyond it, space continues, but the story is unreadable. It is like standing by the sea at dusk. The waves stretch out endlessly, but beyond a certain distance, they blur into mist and darkness. You know the ocean continues, but your eyes cannot follow it. And yet, within that horizon, there is more than enough to keep us wondering forever. Hundreds of billions of galaxies, each filled with billions of stars, each perhaps surrounded by worlds. If time itself is vast, so too is the canvas it paints on. The horizon may limit our sight, but it does not limit our imagination. When scientists first began to suspect that the universe had an age, it wasn't clear whether it was eternal or finite. For centuries, philosophers imagined a cosmos that had always existed, steady and unchanging, an infinite stage with no beginning and no end. But the evidence of expansion shifted that perspective. If galaxies are moving apart today, then in the past they must have been closer together. Keep winding the clock backward, and eventually, you arrive at a time when everything was compressed into a dense, hot state. This is the essence of the Big Bang, not an explosion in space, but the expansion of space itself from an earlier, compact condition. It marked not just the beginning of galaxies and stars, but the beginning of time as we know it. To speak of before the Big Bang is slippery because time itself was part of what emerged. Asking what happened before may be like asking what is north of the North Pole. Yet within that beginning lies the foundation for the universe's age. By studying the afterglow of the Big Bang, the cosmic microwave background, scientists can trace how long space has been expanding. By measuring how fast galaxies drift apart today, they can calculate how long it has been since they were all in that earlier, denser state. The result is remarkably consistent, about 13.8 billion years. That number carries a kind of poetry. It is precise enough to be scientific, yet so vast it slips past ordinary comprehension. Imagine 1 year for every grain of sand on all the beaches of Earth. Even then, you would not have enough to count 13.8 billion. Imagine writing down the years as numbers, filling book after book, until the shelves bent under their weight. That stack would only just begin to capture the immensity of cosmic time. And yet, there is comfort in this bigness. The age of the universe is not abstract, but personal. Every atom in your body, every molecule of air you breathe, was forged in that unfolding. Some atoms were born in the fireball of the Big Bang itself. Others were created later in the cores of stars and spread out when those stars died. To measure the universe's age is also to measure the history written inside us. When you close your eyes and let your thoughts drift, imagine yourself as a small note in a grand symphony, one that has been playing for billions of years before you arrived and will continue long after. The age of the universe is not just a number, it is a melody, and you are part of its song. One of the most fascinating ways astronomers measure the universe's age comes from the light curves of dying stars. These are known as white dwarfs, the compact remnants left behind after stars like our sun exhaust their fuel. When a star like the sun finishes shining, it doesn't explode like a supernova. Instead, it sheds its outer layers and leaves behind a glowing ember, a white dwarf that slowly cools over time. This cooling is steady and predictable, like a log of wood fading into ash. Because of this, white dwarfs act like cosmic clocks. By measuring their temperature and brightness, scientists can estimate how long they have been cooling. When astronomers look at the faintest and oldest white dwarfs in our galaxy, they find ages that line up beautifully with other cosmic measurements, again pointing to a universe about 13 to 14 billion years old. Another clock lies in the chemistry of ancient stars. Some stars contain elements created by radioactive decay, such as uranium or thorium. These atoms decay at fixed, known rates. By measuring how much of them remains compared to their decay products, astronomers can estimate how long those atoms have existed. It is the same principle as carbon dating on Earth, but instead of fossils and bones, we are dating the galaxy itself. The result? Ages that once more agree with the picture painted by expansion and background radiation. It's remarkable that so many independent methods, galaxies drifting apart, the glow of the Big Bang, the fading of white dwarfs, the decay of atoms, all converge on the same story. Each one is like a different voice in a choir, singing the same note in harmony. The universe is old, unimaginably so, but not eternal. It had a beginning, and we can measure the time that has passed since then. There is a quiet reassurance in this consistency. Imagine sitting by a fire with many clocks ticking softly in the background. Each clock is different, one chiming, one digital, one old and mechanical, but they all keep the same time. You feel at ease knowing they agree. That is what science has given us. A room full of cosmic clocks, each pointing to the same great age. And perhaps the most humbling part is this. Even with all our telescopes, satellites, and equations, we are still only scratching the surface. 13.8 billion years is what we can measure. But whether the universe will last another billion, or a trillion, or something beyond even numbers, is still a mystery. The future stretches out ahead, as silent and unknowable as the stars. If the age of the universe is a story written in starlight and background radiation, then telescopes are our libraries. Each new instrument lets us reach farther back in time, closer to the beginning. The Hubble Space Telescope, launched in 1990, gave us some of the first clear glimpses of the most distant galaxies ever seen. Its deep-field images showed tiny smudges of light, each a galaxy billions of light-years away, shining to us from a time when the universe was only a fraction of its current age. And then came the James Webb Space Telescope, launched in 2021, designed to peer even deeper. With its infrared vision, Webb can see light that has been stretched by billions of years of cosmic expansion. Looking through Webb is like looking through a window that grows clearer the farther back you go. Already, it has revealed galaxies forming just a few 100 million years after the Big Bang, their light carrying the echoes of cosmic dawn. Each of these discoveries refines our estimate of the universe's age. They are not contradictions but refinements, like polishing a lens until the picture comes into focus. Each faint galaxy, each flicker of light, tells us not just about itself, but about the timeline of everything. When we say the universe is 13.8 billion years old, it is not a guess pulled from the air. It is the result of layer upon layer of evidence, converging from all directions. Expansion rates, star ages, background radiation, galaxy formation, all sing the same number with only the slightest variations. It is as if the cosmos is whispering its age to us in every possible language, and we are finally learning to listen. And yet, there is something dreamy about it all. Because when we look back at those ancient galaxies, we are not just measuring time, we are experiencing it. The light entering your eyes tonight may have left its source when Earth itself did not exist, when the Milky Way was still assembling, when the universe was impossibly young. To measure cosmic time is to connect with it directly, to let photons become messengers carrying the story of forever. Close your eyes for a moment and imagine that a universe filled with clocks made of stars, each ticking not in seconds or minutes, but in billions of years. Each glow, each faint flicker, is telling you where you are in the great river of time. And all together, they form a lullaby of numbers so vast they stretch gently into the dark. Even with all these measurements, there is still a puzzle hidden in the numbers. The age of the universe depends on how fast it has been expanding, and that speed is measured by something called the Hubble constant. Named after Edwin Hubble, it tells us how many kilometers per second galaxies move away for every megaparsec of distance. The problem is, different methods of measuring it give slightly different answers. When we measure the expansion using the cosmic microwave background, the afterglow of the Big Bang, we get one number. When we measure it using nearby galaxies and supernovae as cosmic mile markers, we get another. The difference is small in percentage terms, but huge in its implications. If the expansion rate is faster, then the universe is younger, closer to 12.5 or 13 billion years. If it is slower, then it stretches comfortably to 13.8 billion. This tension is called the Hubble tension, and it's one of the great mysteries of modern cosmology. Some scientists think the discrepancy will vanish with better measurements. Others suspect it hints at new physics, something beyond our current understanding. Perhaps dark energy, the mysterious force accelerating the universe's expansion, behaves differently than we expect. Perhaps there are subtle effects in the early universe that left fingerprints we haven't deciphered yet. Whatever the answer, the tension reminds us that even our most elegant clocks can disagree, and that science is always an unfinished story. But even with this uncertainty, the broad picture holds. The universe is more than 13 billion years old, and its history is written into the fabric of space itself. What began as a mystery about whether the cosmos had a beginning at all has become one of the most precisely measured ages in science. And still, the debate hums quietly in the background, like a soft, dissonant note in an otherwise harmonious song. There's a strange comfort in that, too. To fall asleep to the idea that the universe is both knowable and mysterious, precise and uncertain. That even as we cradle the number 13.8 billion years, we are aware that it could slip slightly, change shape, reveal something new. Like the stars themselves, the age of the universe twinkles, not fixed, but alive with possibility. When we talk about 13.8 billion years, the mind struggles to hold it. Numbers that large don't feel like numbers anymore. They feel like abstractions, like poetry disguised as math. To make sense of it, scientists often compress the universe's timeline into a single cosmic calendar. Imagine the entire history of the universe mapped onto a single year. In this calendar, the Big Bang happens at midnight on January 1st. Galaxies form in February. Our Milky Way comes together in spring. The first stars burn out, heavy elements scatter, and new stars are born. By September, the solar system takes shape. Earth forms, oceans fill, and life begins. Dinosaurs don't appear until December 25th, humans until late on December 31st. Recorded history? Just the last few seconds before midnight. This calendar is not just a teaching tool. It is a reminder of how young we are. Compared to the age of the universe, our entire existence has been a blink, a whisper at the end of a long symphony. And yet here we are, thinking about that symphony, asking how long it has been playing, daring to measure forever with our fragile instruments. There's something deeply humbling in that. Our species didn't need to know the age of the universe to survive. Ancient people lived by the rhythm of the seasons, not by the ticking of cosmic clocks. But still, curiosity pulled us outward, to the stars, to the galaxies, to the beginning of time itself. That curiosity is why we know today that the universe is 13.8 billion years old. And that curiosity is what will carry us to whatever discoveries come next. So when you hear that number, don't think of it as just digits on a page. Think of it as a story stretched across eons, a melody written in starlight. Think of it as every photon that ever crossed the void to reach you. Think of it as time itself, stretched and folded until it finally whispered the answer in our ears. And remember, the number will never feel real. But the wonder behind it always will. If the universe has an age, it also has a future. Measuring the past isn't just about knowing when the Big Bang happened. It's about tracing the trajectory forward, asking how long the cosmic clock will keep ticking. The expansion of the universe, the same motion that helped us calculate its age, also hints at what lies ahead. For a long time, scientists thought gravity would be the dominant force. Galaxies, stars, and all the matter of the cosmos would tug on each other, slowing the expansion. Maybe it would stop one day, maybe even reverse in a grand collapse, a big crunch. In that view, the age of the universe would be half its story, the midpoint between birth and death. But then came the discovery of dark energy, the mysterious force driving galaxies apart faster and faster. Instead of slowing down, the expansion is speeding up. This changes the entire arc of the story. If dark energy continues as it is, the universe will expand forever, growing colder and dimmer with time. Stars will burn out, galaxies will drift beyond each other's sight, and the cosmos will fade into quiet. Not with a bang, but with a long sigh into darkness. This doesn't mean the universe is ending anytime soon. On human timescales, even on planetary timescales, it will go on almost unchanged. But knowing the age helps us place ourselves within that larger curve, to see where we are in the unfolding drama. At 13.8 billion years, the universe is still young compared to its possible future. There could be trillions upon trillions of years ahead, time enough for countless stars to be born and fade away. It's an odd kind of comfort, isn't it? To think that while our lives are short, the cosmos stretches out in a patience beyond comprehension. Our story is just a verse in a much longer poem. And when you fall asleep thinking about the age of the universe, you can also dream about its future, quiet, vast, and still being written. So here we are at the end of our long walk through time. We began with a question: how do scientists measure forever? And we found that forever has markers. It hides in the glow of ancient starlight, in the cooling of white dwarfs, in the fading whispers of radioactive elements. It lives in the stretching of galaxies, in the faint afterglow of the Big Bang, in the cosmic calendar that shrinks eternity into a single year. Each of these clocks, fragile and powerful, points us to the same truth. The universe is old, unimaginably old, about 13.8 billion years, give or take a little uncertainty that keeps things honest. And yet, that number is not the end of the story. The more we measure, the more we realize that time itself is not something to conquer or contain. It is the fabric we live in, the rhythm beneath every heartbeat, the quiet backdrop to every star. To ask about the age of the universe is to step into a vast silence and dare to listen. And what we hear is not a final answer, but a melody that stretches on, soft, patient, infinite in its mystery. Perhaps the most soothing part of it all is knowing that we don't have to resolve every question. The tension in the Hubble constant, the unknown nature of dark energy, the speculation about what might come after trillions of years, these are not flaws. They are invitations. They remind us that science is not about closing doors, but about opening them. So tonight, if your eyes grow heavy as you think about starlight that has traveled billions of years to meet you, let it lull you the way the universe itself has lulled galaxies into their slow dance. Let the vastness be a comfort, not a weight. Let the questions drift like constellations just out of reach. And if you fall asleep with the thought of forever still echoing in your mind, that is its own kind of answer. Because in the end, the age of the universe is not just a number. It is a story, and like all good stories, it stretches beyond the page, carries us, gently, into wonder. And maybe that's the truest measure of forever, not how long it lasts, but how deeply it moves us, how quietly it stays with us, even in the space between waking and dreams.